In this section, we will learn about the Parvartya Yojayat Sutra of Vedic mathematics, which means transpose and apply. Let's take a look at the applications of this sutra in mathematics. Parvartya Yojayat generally is used for division of numbers. Using Parvartya Yojayat, we can divide any number by a number which is more than one digit and slightly greater than powers of 10. For example, numbers like 12, 14, 102, etc. Parvartya Yojayat can also be used for division of algebraic equations. Let's learn how to use this sutra for division of numbers. Using this sutra, we can divide any number, let's say x, by numbers which are more than one digits and are slightly greater than powers of 10. For example, x by 12, 14, 102, etc. One important thing to note is that using this method, we will find answer in terms of quotient and remainder. For example, if we divide 5 by 2, the quotient is equals to 2 and the remainder is equals to 1. Why? Because 2 into 2 plus 1 is equals to 5. So this is remainder and this is quotient. Now let's take an example to learn how this works. Let's divide 1225 by 12. The first step is we will write the divisor, which is 12, here. Now we'll transpose this second digit of the divisor in terms of the negative sign or the positive sign. So since this is 2, which is positive, we write minus here and this 2 here. The first number will be ignored. In the second step, we'll write the dividend, which is 1, 2, 2 and 5. Notice that we have written 5 slightly further. Why? Because this part will give us the quotient and this part will give us the remainder. What is important here is we have only written 5 further. That is the last one digit of the dividend. Why? Because this number 12, the divisor is near to base 10. So the remainder will be in only one digit, which is 5 here. Now the third step, we will write this again. Now we'll write a line here and this one will come down as it is. Now we'll multiply this one here with minus 2. So this becomes 1 into minus 2 is minus 2 and write it here. We'll add these two. This becomes 0. Now we'll multiply this 0 with minus 2. So this will become 0. We'll add these two. So this will become 2. Now we'll multiply this 2 with minus 2 again. This becomes minus 4 and we get 1 as the addition of these two. We have to stop as soon as we reach this part, as in both the lines are filled till the last number. So here the answer quotient is equals to 102 and remainder is equals to 1. Let's take a look again how this technique is working. So the first step is to write the divisor, remove the first digit and transpose the second digit to negative sign. Second step, write the dividend and separate it by last digit, since in this case the divisor is near to the power of 10. In the third step, we'll write down 1 as it is here, which is the first digit of the dividend. I will multiply the first digit of the dividend here with minus 2, which is the transpose of 12. and write it here. Then we'll add these two, we'll get 0. Again we'll multiply 0 into minus 2, so we'll get 0. We'll again add these two here, so we'll get 2. Now we'll multiply this 2 with minus 2 again, we'll get minus 4, and we'll add these two, so this is 1. So thus we'll get our answer as quotient is equals to 102 and remainder is equals to 1. Now let's take some more examples. We'll divide 1697 by 14. So write 14 here, transpose it, we'll get minus 4. Now we'll write 1697, write 1 as it is, multiply this 1 with minus 4, so this becomes minus 4. Add these two, this becomes 2. Multiply 2 with minus 4, this becomes minus 8. Add these two, this becomes 1. Now multiply this 1 again with minus 4, this becomes minus 4, and this is 3. So the quotient is 121 and the remainder is equals to 3. Let's see one more example. Let's divide 2598 by 123. So 1, 2, 3. Let's transpose it. Ignoring first digit, it becomes minus 2, minus 3. Now we'll write 2598. Here we are separating two digits because 123 is the 3-digit number near to base 100. So the remainder will be in 2 digits. We'll write this 2 as it is. Now let's multiply this 2 with minus 2 first and then with minus 3. So 2 into minus 2 is minus 4. 2 into minus 3 is minus 6. Adding these two, we get 1. We'll not add this here now. We'll only add it one by one. What we'll do is we'll multiply this 1 with minus 2 and with minus 3 now. So multiplying 1 with minus 2 gives us minus 2 and 1 with minus 3 gives us minus 3. Now we'll add this. 9 minus 6 minus 2 is 1. 8 minus 3 is 5. So quotient is equals to 21 and remainder is equals to 15. Let's take one more example. We'll divide 239479 by 11213. Don't worry by looking at this number. It's again very simple to divide. We'll follow the same method. So this becomes minus 1, minus 2, minus 1 and minus 3. We'll write 239479, which is our dividend. This is separated by 4 digits here because again the divisor is a 5-digit number, so it will have remainder in 4 digits. Now we'll write this first digit as it is here 2. Now we'll multiply this 2 with each one of these here. So this becomes 2 into minus 1 is minus 2, minus 4, minus 2, minus 6. Add this 2, so this becomes 1. Now we'll again multiply this 1 with each one of these here. So we'll write here minus 1, minus 2, minus 1 and minus 3. Since we have reached the last here, we'll add all of them. 9 minus 4 minus 1 is 4. 4 minus 2 is 0. 7 minus 6 minus 1 is 0. 9 minus 3 is 6. So here the answer is quotient is equals to 21 and remainder is equals to 4006. Till now we have only taken examples when remainder comes as positive. What happens if the remainder comes as negative when we are solving for it? Let's take one example and understand how we'll solve for that. So 13456 divided by 1123. We'll write 1123 here. minus 1, minus 2, minus 3. We transposed it. Now we write 1, 3, 4, 5, 6. Last 3 digits are separated because we have 4 digits in the divisor. Now that's all. This 1 comes here as it is. We'll multiply this one with minus 1, minus 2 and minus 3. So this becomes minus 1, minus 2, minus 3. Add this 2, so we get 2 here. Now we'll multiply this 2 again with minus 1, minus 2 and minus 3. So this becomes minus 2, minus 4 and minus 6. Now we'll add it. So this is 0, minus 2 and 0. Basically this is 12 and this is minus 20. Now we notice that the remainder here is coming as negative. Let's see what's happening here. So basically 1, 3, 4, 5, 6 now can be written as 12, which is the quotient, into the divisor, which is 1, 1, 2, 3, plus the remainder, which is minus 20. So we can rewrite this as 11 into 1, 1, 2, 3 plus 1, 1, 2, 3 minus 20. Now notice that what we have done is we have taken 1 from the quotient and then we have moved it towards the remainder part. So similarly we can do it here. So this makes it 11 and we move 1 quotient, which is 1, 1, 2, 3 minus 20. So we get our answer as quotient is equals to 11 and remainder is equals to 1, 0, 2, 3. Let's take another example. We'll now divide 1, 2, 3, 4, 9 by 133. So 133 becomes minus 3, minus 3. We'll write it 1, 2, 3 and 4, 9. The last 2 digits are separated for remainder. Let's start the process. 1 comes down as it is. So 1 into minus 3 into minus 3. So this becomes minus 3, minus 3. This becomes minus 1. Now we'll multiply this minus 1 with minus 3 and minus 3 again. So minus 1 into minus 3 is 3. Minus 1 into minus 3 is 3. Add this. This becomes 3. Now we'll multiply this 3 with minus 3 and minus 3. So this becomes minus 9. This becomes minus 9. Add this. This is 0. This is minus 2. So which is 1, 1. We'll put a bar here since this is negative. 3 and minus 20. Such kind of numbers are called vinculum numbers, which we have seen in our previous sections. So this will become 93 and this is minus 20. Now again we'll take one quotient and move it towards the remainder part. So this becomes 92 and 113 minus 20. So the quotient is 92 and the remainder is 113. If you don't remember how we have converted 1 bar 3 to 93, let's just take a look here. 113 with the bar here is a 3-digit number, so it can be written as 100 into 1 for the 100th place plus 10 into 1 bar or minus 1 and 1 into 3, which is the units digit. So if you add this, this will become 93.